Hi everybody. Today we're going to review for the test. This has more questions than the test, but all of this stuff is on the test. So switching from degrees to radians or vice versa. Remember, it's all about the pi symbol. If you want radians and you want the pi on the top, pi and 180 are equivalent, so 180 on the bottom. Now when you put this in the calculator, you can just do 310 divided by 180, not the pi, and then take care of the pi yourself, put the pi back in. But the zeros cross off here, so it's just 31 pi over 18. For negative angles, if it's negative radians or negative degrees, they stays. So negative stays negative. Again, 155 divided by 180. Then go to math, enter, enter. Switch it back to a fraction and put the pi back in the numerator. Take care of the pi symbol yourself. Now when we're trying to get rid of the pi, put that on the bottom. Now this is just regular arithmetic. 7 times 180 divided by 3 is 420. In degrees, please put the degree symbol on your answer. And here again, negative radians will be negative degrees, so this is negative 80 degrees. Now to find the quadrant that it lies in, you might want to draw it or think about how does it compare to 360 or 180, whatever works for you. I always have to sort of draw it. Like obviously, if we think about negative, so it goes down, there's 270 right there. So it's a little bit more. It's not all the way around, but it's right in that first quadrant. And then you're going to take your angle and you're going to add 360 and you're going to subtract 360. So we get 75 degrees and negative 645 degrees. When it's in radians, remember this line over here is 3 pi over 3, 7 pi over 7. So in this case, we want it to be 5 pi over 5. Negative again, so we're going down again. So that would be negative 5. So we're not, this would be like 2.5. You want to think about halfway. We're not going really past 5. So it'll be right there. And that is in quadrant 3. And of course, same deal. We want to find the negative and positive angle. Now with this one, you want to add and subtract 2 pi. Now in your calculator, you can just add and subtract 2. So negative 3 divided by 5 plus 2, hit enter. Math, enter, enter. Put the pi symbol back in the numerator yourself. If you put the pi in the calculator, it'll treat it like a decimal and it'll never switch it back to a fraction for you. When you subtract, you get negative 13 pi over 5. Definitely, that was maybe too many. There aren't that many of those on the test. Just plain old trig, just plain old regular trig. We don't pay attention to too much. Is it sine? Is it cosine? Is it tangent? Very, very basic. So this is the angle. So this is your opposite side. This is the adjacent side. So this will be tangent. Then the angle follows immediately after that. And then follow the ratio. So it's opposite over adjacent. When the x is in the bottom, we divide. So the 23, or this number, always goes in the calculator first because the word and the angle are stuck together. Make sure your calculator's in degrees. 23 divided by tangent of 64 means that x is 11.22 because we're going to 2 decimal places according to the directions. For this one, according to this theta, this would be your hypotenuse. This is adjacent. Hypotenuse and adjacent is cosine. So cosine, we don't know what the angle is, and this would be 24 over 37. When your angle is missing, you have to do inverse. So you have to do second cosine and then do 24 divided by 37. We're still rounding to 2 decimal places for all the answers. 49.56 degrees. And for this last one here, this is opposite, this is hypotenuse. So opposite and hypotenuse is sine of 22 is equal to x over 19. And then this is the other kind you could have, where the letters on the top. This is a multiplication problem, so it would be 19 times the sine of 22 in the calculator. And we get x equals 7.12 when we round to 2 decimal places. Then we had the kind where you had to draw your own triangle. Whether it's angle of elevation or angle of depression, that angle can always go in this corner. Or if you're going to draw your triangle this way, it will go in this corner. So it doesn't matter if it says angle of elevation or angle of depression, it's going to be in the same spot. So here we have our wall. We're going to assume that the wall makes a right angle with the ground. And we have a 30-foot ladder. It is the ladder that's on the diagonal. The base of the ladder is 17 feet from the bottom. Find the angle of elevation. So we're looking for this angle. If you drew it this way, the 30 would be here, 17 here, and that's, of course, your x. It doesn't matter which way it's oriented. It's still adjacent over hypotenuse, which is cosine. So cosine of x is equal to 17 over 30. So this is an angle again. So when we're missing an angle, you do second cosine and then put that in the calculator. So the angle is 55.48 degrees. Now in this next group, we had two different ways that we did all 6 trig functions. One if you're given a point, or one if you're given one of the trig ratios. So with a point, plot it like the point. Right, so positive, negative, so put it in the correct quadrant. So we're going to go right 2, we're going to go down 11. And so when you draw your triangle, you always connect it to the 0, 0, and you only connect it to the x-axis. So this line will be to the x-axis, that's where your angle is. So always to the 0, 0. Now we have to use Pythagorean theorem to figure out what the missing side is. So 2 squared plus 11 squared, and we're missing that side. So that's 125. Oh, it's perfect square, so 15. Now your hypotenuse will never be negative, so we don't have to worry about putting a sign on that. And now you can just use SOHCAHTOA. They've got them all set up for you here. So the reciprocal is also in this column, so immediately next to it you have your reciprocal. You don't have to really think too much about it. So your angle is always up here by the 0, 0. Opposite, that's your negative 11. Adjacent is the 2, 15 is the hypotenuse. So we would have negative 11 over 15 for this one, and then flip it over, negative 15 over 11. Cosine would be 2 over 15, and both of those are positive. Now cosine's positive in that quadrant, so that makes sense. So 15 over 2, we flip it over. And tangent's negative in this quadrant, and it would be negative 11 over 2, and this would be negative 2 over 11. None of those need to be reduced, so that worked out kind of nice. So now for number 12, we have a little different situation. We have to figure out where we are based on these little clues about whatever the trig functions are. So the cosine is negative. All scholars take calculus. Cosine is not negative here or here. So those two quadrants get eliminated. It also says the sign is negative. That's a fancy way of saying negative. So the sign's positive here, so that takes you to right here. That's the only quadrant this can be in. So now we know where we are. That's what the triangle would look like. Cosine is negative 6 over 7. That's adjacent over hypotenuse. Don't worry too much about the sign. Put it on the triangle and try to make sense out of it. So the adjacent is 6, the hypotenuse is 7. Well, your hypotenuse can never be negative. So that means the 6 is negative. Makes sense because we went to the left. So it works with the graph. Now we got to use Pythagorean theorem. I'll call that side x, don't know what it is. Plus 36 is equal to 7 squared, which is 49. So move that 36 over there, we get 13. So our missing side is the square root of 13. Now remember, you cannot have a radical in the bottom, so we might have to fix some of these. The angle is, of course, always in this corner, so there's our angle. So the radical 13 is the opposite side. That helps kind of identify what we're doing. So the sign will be, oh, this is also negative because it went down. Negative radical 13 over 7. And then this would be negative 7 over 13, radical 13, so we got to rationalize it. So we get negative 7 radical 13 over 13. Cosine, we already know that one. They gave us that, so that's nice. Flip it over. Tangent is opposite over adjacent, so these are both negative. And you already know, right, all scholars take calculus. So tangent's positive there, so it kind of goes together with what we know to be true. And then when you flip this over, you get 6 over radical 13, and we have to rationalize it. So this is 6 radical 13 over 13. Now we're just drawing angles. This is kind of a big deal. Knowing where they're located, being able to show if it spins around more than once, show the direction in which the angle spins. So 164, whoa, sorry about that. not only are we drawing this, but we're finding the reference angle. So the picture is supposed to be helpful, and I'll show you why. So 164, right here is 180. So we're kind of not all that way. Well, you know your reference angle lives right here. This is your reference angle. The space between the angle and 180 when you're in that quadrant. So you subtract 180 minus 164. Reference angle is 16 degrees. Negative 461, clearly more than once around. So when you show that it spins, show that it spirals out. So here we go, we're going around. There's negative 360. And then if we think about, there's another 90. We don't have to go that much further. So we're in that quadrant somewhere. It doesn't really matter. We're just in that quadrant. So now what we have to do is figure out how far away we are. I would try to whittle this down a little bit better, like negative 461, or even get rid of the negative, and then subtract the 360. And now we're at 101 degrees, but we're trying to draw this to here. So we need to know, well, how far is 101 from 180? And that, of course, is 79 degrees. In radians, of course, your answer should be in radians. So question in radians, answer in radians. And in radians, we want to think in fractions. So this would be 4 pi over 4 right here. We are spinning, so it's negative. We can switch that to negative or positive. So we're not going all that way. We're not going quite that far. So again, how far is 4 pi over 4 from 3 pi over 4? Well, 1 pi over 4. The fact that they're both negative, we don't care about. Negative controls the direction, and we can just subtract them like they're both positive. 11 pi over 6. Well, this would be 6 pi over 6. Double that, this would be 12 pi over 6. But we're also going, oh no, it's positive. Sorry, I don't know why I thought it was negative. So we're not going quite all the way around. We're going right to here. So how far is 11 pi over 6 from 12 pi over 6? 1 pi over 6. Radians, honestly, are usually a little bit easier to subtract, which is kind of nice. Now, for your unit circle, you will have that to look at. But it's always nice to sort of practice trying it out, seeing if you can remember where these are located. Remember, with negative angles, we do spin down. So it's really right here. It's the same thing as 2 pi over 3. So be careful with that. So this is going to be radical 3 over 2. Some things about your unit circle. Everything goes cosine, sine. So we are looking at the y value there. Secant goes with cosine. So you find the x value, which is negative radical 2 over 3, and then you flip it over. So when we flip this over, oops, sorry, I already did flip it over. You got to rationalize this. Wait, I did this upside. I didn't flip it over. I don't know what I did. Let's get rid of this. Sorry, I'm confusing myself. So the answer flipped over it's really radical 3 over 2, and it's negative. So we flip this over. We get 2 over radical 3, and then we rationalize this. It stays negative, so this is going to be negative 2 radical 3 over plane 3. Cosine, of course, is your x value. Go to 7 pi over 4. It's where it's positive. And cotangent goes with tangent. Now, some tricks about tangent. When there's a 6 in the bottom, it's always radical 3 over 3. If there's a 3 in the bottom, it's radical 3. So when we do the reciprocal of this number, it's just radical 3. Now, if you have to write it out and rationalize it, that's up to you. But that you were given all kinds of shortcuts there to help you kind of work through that a little faster. Shortcut's only good, though, if you can remember it. And then, of course, your graphs. You'll have a few graphs. So I put some of the weird ones on here just for practice. Tangent has no amplitude, ever. Period is 1 pi over b. So this is going to be pi divided by 2/3, which is the same thing as pi over 1 times 3/2. So our period is 3 pi over 2. Phase shift, so we're not moving left or right. And vertical, we're not moving up or down. As you know, I'm just going to say it like that. Tangent starts one space to the left of the y-axis. It must start there, unless you move it so far to the right that it doesn't. Also, when you take the period, I want you to double this, so we have room 1, 2, 3, 4. Normally we'd put the period there, but we're going to take 3 pi over 2, and we're going to multiply it by 2. So that's 3 pi. So then this is half of that, which is 3 pi over 2, and then 2 spaces the other way, negative 3 pi over 2. And then all you have to do, one space to the left of the y-axis, tangent, asymptote, 0, asymptote, 0, asymptote. And if you do it right, you should have one sticking out to the left and one sticking out to the right. And then we just draw it in there. For cosine, all the parts. We have an amplitude, right? That's the first number. The period is 2 pi divided by b. So that's going to be 2 pi times 3/2, just like we just did, although it was 1 pi up there. So this is now 3 pi. Phase shift, of course, we are going left because it's positive. 3 pi over 4. Please don't write plus 3 pi over 4. Use words so that I know that you know. And then, of course, this is down because it's negative. Don't just write -1. I can see that it's -1. Right? I want you to interpret what that means, please. So since we're going to the left, I'm going to give myself some space. We also are going to go down 1. And we have to be able to go 2.5 up. That's too many. I know, I just went for it. And we have to go 2.5 down. This is -2, negative. That's also too many, but I just am labeling. And then we have our period, 1, 2, 3, 4, 3 pi. Here's 3 pi over 2, which means one space. Right? If we take 3 pi over 2 and multiply by 1/2, that's 3 pi over 4. So halfway between there. So we're moving this thing one space that we drew. So make sure you have some stuff on the left of the y-axis. Now you can move it and graph it, or you can move it and then graph it. We also need this dotted line for our new midline. I'm going to move it, and then I'm going to graph it. So I'm going to graph it in blue and then move it and show the real graph. It does not reflect, so cosine starts high. So it should start up 2.5. So at 1.5, and it should end, of course, we're counting from the dotted line now, not from the axis. And then we count down 2.5, so at -3.5. And then right in the middle, right between the two that are not labeled, get the zeros. Now we're going to move these these 5 dots to the left one space. So this will be our first starting point. And then we have this point, 3 pi over 2, of course, it's right there. This one's going to be right on my numbers, and then this one's right here. And then I'm going to connect these darker circles. There it is. And cosecant. For cosecant, remember we graph the sine, but you answer the questions like it's cosecant. So there is no amplitude, but we will use that when we go to graph it. Period is 2 pi over b. We don't moving this left or right, but we are moving this thing up 2. And we've got to be able to see the 3. And we have to be able to see 3 down from 2. So we have to go down to -1. And then, of course, 4 spots. Period goes here, halfway, please. And we're moving this up 2, so I'm going to put my midline there. Midline's super important. Please draw it. And now we graph this. Now we're graphing the sine. So sine has a 0 in the beginning, in the middle, and the end. And sine goes up before it goes down. So it goes up 3 from here. And then it also goes down 3 from right here. Right? So we count from here. This is not the graph. We want to do the reciprocal. So the reciprocal means take your zeros, turn those into asymptotes. And the high point means the arrows go up. The low point means the arrows go down. Now your sine graph lives right inside here, and it shouldn't interfere. So that might help you kind of draw those little parabola looking shapes. It should not touch the sine graph. Now you don't have to draw the sine graph, but it is there. So all of these questions, these style of questions will be on the test. It won't be this many questions, but you'll have to do everything that you see on this paper.